Hi folks, this is Karim Raouf for IT Visualizer channel. They will continue our lab, the matrix labs, the video number 100. We have been discussing in the previous video the following. We are still working with the topic of troubleshooting and repairing Windows operating system using SFC and DISM tools. Okay, as we said before in the previous two videos or the previous three videos, that your last resort is to reinstall or reload the Windows operating system. You need first to take all the steps needed to repair it or repair the operating system before taking the decision to reinstall or wipe completely the operating system and reinstall it from scratch. So we have seen a lot of or we have discussed the SFC and DISM commandlets, and we have seen that they are useful and we can repair the Windows while you can still log into it, which is called online repair, and we can repair the Windows when you cannot log into it, which is called offline repair. And the two processes are a little bit different. You need to be a little bit cautious and a little bit focused when you try to repair the Windows when you are offline. Okay, you need to make sure that you are repairing the correct partition which contains the operating system. We need to make sure that the DISM commandlet will repair your Windows operating system, not through getting or through getting the healthy files from the internet. It should be redirected to get the healthy files from your bootable flash drive. We have discussed this topic in the previous video. So today we will try to give the AI tools the PDF of Mr. Lo van der Poel. So we have I already feed up most of the AI tools with the PDF of Mr. Lo van der Poel. If we go and have a look, let me try to get just a moment, guys. I think I need to get the PDF. Here you go. This is the PDF. Just wait for a moment. We have the D partition and I have the matrix videos, and then we have this PDF. If we go there and try to have a look, here this is the PDF. So what I have done, I have already go to three AI tools. The first one is Google AI Studio, and I am currently working with Gemini experimental 1206 module, which is the best one from my point of view. Gemini 2 Flash is not that, it's not that good from my point of view, or it is a brief one, or its answer is brief. The Flash and experimental thinking. Okay, I tried both, so I will use this as the best utility I have found from Google. Okay, what I have done, I have already uploaded the PDF and ask it to analyze this PDF and type confirm and wait for any query for me concerning the content of the PDF. This is the first one. As for ChatGPT, I have already created a folder, okay, and added the PDF. I have created a project and added the PDF to this project, and then I begin asking him to uh, uh, answer my questions based on the project files that I have already fed him up with. Okay, so this is the second AI tool. So let's continue, guys. Here this is the second AI tool, and then the third AI tool, which is Claude 3.5 Sonnet. Again, I have already created a project in Claude, and if we go there to the project itself, I have already added Mr. Lo van der Poel PDF, and I am asking Claude to explain it, okay, and give me exercises and a lot of things from this PDF. So let's go and begin with Gemini, the first AI tool. And here, after giving him this prompt, Tell him to explain how to repair Windows 11 using SFC and DISM. Okay, how to repair Windows 11 using SFC and DISM. Do this by exploring the video notes how to repair Windows 11 using SFC and DISM PDF, okay, from the project files. Like I'm a junior IT administrator, show how this concept works, provide a real-world scenario, and include common pitfalls. So let's see the answer.
Okay, let's break down how to repair Windows 11 using SFC and DISM. These are essential tools for any IT admin, and understanding them will save you a lot of headaches. Think of them as your go-to utilities for fixing corrupted system files and issues with the Windows image itself. How SFC and DISM work. The basics. SFC, System File Checker SFC, is like a spell checker for your Windows system files. It scans the integrity of all protected system files and replaces corrupted or modified files with cached, correct versions from the WinSXS folder component store. You can run it with the /scannow command. DISM, Deployment Image Servicing and Management DISM, is a more powerful tool. It can repair the Windows image itself and the component store WinSXS, which is crucial because SFC relies on a healthy component store to fix system files. DISM can use Windows Update or a local source, like an installation ISO, to obtain the necessary files for repair. How the concept works, a deep dive. The problem. Windows relies on thousands of system files to function correctly. These files can become corrupted due to various reasons. Faulty updates, software conflicts, driver issues, malware, or even sudden power outages. SFC to the rescue. Usually when you suspect system file corruption, SFC is your first line of defense. It compares the current system files against the cached versions in the component store. If it finds discrepancies, it replaces the corrupted files with the good ones. The component store, WinSXS, this is where Windows stores different versions of system files. It's like a library of files that SFC and DISM can borrow from. When SFC isn't enough, sometimes the component store itself can become corrupted. In these cases, SFC might fail because it can't find the correct files to use for repair. DISM steps in. This is where DISM comes in. It can repair the component store using files from Windows Update or a specified source. Once the component store is healthy, SFC can usually do its job correctly. Real-world scenario. Let's say users in your company are experiencing blue screens of death, SODs, after a recent Windows update. You suspect that some system files might have been corrupted during the update process. Initial assessment. You start by gathering information, error messages, event logs, and when the issues started occurring. Run SFC. You open an elevated command prompt or PowerShell and run SFC/scannow. SFC scans the system files and reports any integrity violations. If you are unable to boot to Windows, you can use the recovery console. Make note of the drive letters for both the recovery partition and the Windows partition. Then run SFC/scannow/offbooter equals recovery boot partition drive letter //offwindow equals Windows 11 system partition letter /Windows. Analyze SFC results. If SFC finds and fixes errors, great. You reboot the system and monitor for further issues. If SFC finds errors but cannot fix them, it's time for DISM. Run DISM. You use the DISM/online/cleanupimage/restore health command. This tells DISM to check the component store's health and repair it using files from Windows Update. DISM will inform you whether the component store is reparable or not. If it is not, then you will need to perform an in-place upgrade or a Windows reset. If it is reparable, then you may proceed. Rerun SFC. After DISM completes, you run SFC/scannow again to ensure all system files are now intact. Further troubleshooting. If the issues persist, you'll need to investigate further. Check for driver problems, look for recently installed software that might be causing conflicts, or even consider a system restore or a clean install of Windows as a last resort. Common pitfalls to avoid. Not running as administrator. Both SFC and DISM require administrator privileges. Always open the command prompt or PowerShell as an administrator. Ignoring DISM errors. If DISM encounters errors, pay attention to the error codes. They often provide clues about the issue, e.g., network connectivity problems if DISM can't reach Windows Update. Not having a reliable source. If you're using a local source for DISM, make sure it's the correct version and build of Windows and that it's not corrupted. Overusing /reset base. The DISM /online /cleanup image /star component cleanup /reset base command should be used sparingly. It removes all superseded versions of components, making it impossible to uninstall previous updates. It will also remove all your existing restore points. Skipping SFC after DISM. Always run SFC after using DISM to repair the component store. DISM fixes the store, but SFC fixes the system files. Running checkdisk without the /f parameter. This may report spurious errors because it cannot lock the drive. Using the /f parameter corrects errors on the disk. Running DISM /restore health on an internal WSUS. If your computer has no direct internet access, this command will fail. You may need to perform an offline repair using install.vim. In essence, SFC and DISM are powerful allies in your fight against Windows corruption. Understanding how they work together and being aware of common pitfalls will make you a more effective IT administrator. If you master these tools, you'll be well equipped to handle a wide range of Windows issues.
So this answer seems to be a good one. It summarizes all what we were talking about in the previous 3 videos. But again, I think here there is a mistake because SFC scan now off boot driver. This is not the recovery partition drive letter. This is the system or the boot recovery boot partition. Okay, so it's talking about not the recovery partition. This is the boot partition. So if we go to Mr. Low Van der Pol slides, if we open them or open the slides, if we go to the slide itself and try to see the SFC slide, so we can go a little bit deep. Where is the SFC? So I think the SFC is somewhere here, not this one. So we can go deep inside. Where is the SFC? I think maybe this is it. Okay, so this is the specified the boot directory. So drive letter for the root of the Windows partition. This is the correct answer. This is not the boot partition, it's the boot directory. This is good. It's not recovery boot partition, this is the boot partition. Okay, we have 2 off boot driver. This is the boot partition and the Windows partition, Windows 11 partition. So this is the boot partition, not recovery boot. This is the boot partition. So we have 2, one for the boot directory, the letter root for the Windows partition, and the option for the Windows. We have 2. So in some situations, the boot files are in a separate partition than the Windows operating system files. So you need to identify the 2. If they are both on the same partition, then the boot and the Windows directory are the same. The boot directory and the Windows directory are the same if they are on the same partition. Okay, so this is one good answer, and actually he already give us a little bit of a tip that we didn't see in the slides. If we go to this, let me see, because he said, for example, this DISM online cleanup, startup component cleanup, reset base should be used sparingly. It removes all superseded versions of components, making it impossible to uninstall previous updates. It also will remove any existing restore point. Let me get this, or what's talking about this commandlet, copy and try to see ask Perplexity, what does this do exactly, Perplexity AI, because actually I don't know if this is correct or not. Here we can go and ask, okay, what does this uh, commands do exactly, and try to see what will be the answer. So here is talking about it is used to manage and optimize the component store, which is a part of the Windows operating system that holds files related to installed features and updates. Here's a detailed breakdown of the commandlet. We know that DISM, okay, online, options, okay, to run operating system, run on the current running system rather than an offline image. Cleanup image, okay, we know this one. Startup or start component cleanup. This switch triggers the cleanup of surfaced components in the Windows component store. Surfaced components are older versions of files that have been replaced by newer updates. Running this command will help reclaim disk space by removing these outdated files. So he's cleaning the WinSSX from surfaced components. Okay, and reset base. This option is particularly significant as it resets the base of the component store. After executing this command, let all surfaces versions of components will be removed and only the current versions will remain. Importantly, this means that any update that have been surfaced cannot be uninstalled afterward. Essentially, it locks in the current state of updates and components, preventing any rollback to previous versions. So again, how this will impact us. Use implications. Using this command can significantly reduce the size of the WinSX folder, which often grows large due to accumulated updates and components over time. However, it's crucial to understand that once you use reset base, you cannot uninstall any updates that were cleaned up. Therefore, it is generally recommended to run start component cleanup first to clean up any reclaimable uh, packages before applying reset base to ensure that only the necessary components remain. Generally to start cleanup, and then, okay, let's see, I need an example, okay? Run regularly. It's advisable to run this command periodically, especially after major updates or upgrades. I think this is related to Windows update because it stores some files in this folder related to or that is dropped by Windows update. Backup important data before running commands that modify system files or setting. Ensure that you have a backup in case of something goes wrong. Monitor space. After running this command, let's check your disk space to make sure you see the impact of the cleanup. In summary, this commandlet is powerful for maintaining a healthy Windows installation by cleaning up unnecessary files while also lock in the current state of installed updates and components. Okay, let's give me a real world example to illustrate that. So let's see what the example will be. Okay, a user optimizing their Windows 10 PC. Background: Sarah has been using her laptop for over a year. During this time, she had installed numerous updates which have accumulated in Windows X folder, leading to significant disk space consumption. Sarah noticed that her laptop is running slower and that her hard disk is nearly full, prompting to take an action. Action taken: to reclaim disk space and improve performance, Sarah decided to use the DISM command. She opens an elevated prompt running as administrator and run start component cleanup. The command removes older versions of components that had been substituted by newer updates. After running this command, Sarah checks the size of the WinSX folder and see a reduction in size, indicating that some unnecessary files had been cleaned up. Final cleanup by reset base. After confirming that there are no reclaimable packages left, she runs this commandlet. So this command not only removes any unremaining services component, but also resets the component store. As a result, Sarah can no longer uninstall any updates that were cleaned up, effectively locking in her current system state. Outcome: disk space reclaimed. After executing this command, let Sarah notice a significant amount of disk space had been freed up, improving her laptop performance stability. By cleaning up old components and locking in the current updates, her system runs smoothly without remnant of outdated files. Learning experience. Sarah learns the importance of running start component cleanup before reset base to ensure all unnecessary files are removed before locking in the current state. This prevents potential issues where she might want to uninstall and update later but cannot due to having reset base prematurely. So, conclusion, this example illustrates how DISM command can be effectively used by everyday user to maintain their Windows operating system, optimize performance, and manage disk space efficiently while understanding the implementation of each command option used. So here is talking about uh, this removes all services versions of components, making it impossible to uninstall previous updates. It also removes all of our existing restore points. So this is why we need to use it. Okay, maybe we need to clean up our space, reclaim some space, but this is will not help us maybe to fix corrupted files. How this is uh, uh, related to repairing corrupted files? Okay, maybe we need to remove all files from WinSSX which is no longer needed, or uh, uh, it's not needed anymore by the system maybe. But I think also this is not clear how this is related to fixing corrupted files. Okay, I think here is seeking only to clean up or free some space. So this is one thing. If we go and ask uh, ChatGPT the same question, try to get a new window. So here we can ask him to give us O1, then give him this one, and let's see what will be the answer. So there is a problem with O1. If we go to 4 and again ask it the same question, or make a refresh, maybe just a moment, if I ask them and get a new window. Sorry, not this one, I'm actually sorry, this is ChatGPT. So we have this one, we have reasoning. Where is the reasoning one? There is no reasoning. Okay, so we will put this and let's see what will be the answer. Okay, how this could help to repair corrupted Windows Store components or files in WinSSX folder. So he's saying here that these are not directly repair corrupted files, but it can help to improve overall health and stability of the component store in certain scenarios. Here is how it can indirectly contributes. Okay, he's talking about uh, removes outdated and substitute versions of components. If corrupted files are outdated and replaced by newer versions, this can eliminate them from the system. Okay, reset. This is to store the most recent version of the component. This ensures only the latest, most stable versions are retained, which can reduce the risk of conflict caused by corrupted older versions. Okay, so this is how, in indirect way, this commandlet can help us. Reduces system overhead. Cleaning up unnecessary components can reduce the complexity of managing the components stored. It's easier for Windows to resolve corruption uh, issues through repair commandlets. If corruption exists in Windows X folder, uh, you may need to use other DISM commandlets. Okay, we have seen this, that we need to scan health and then check health and then restore health. Okay, and this is if we have online internet access, we can replace the corrupted files using the Windows update, or through bootable DVD, Windows DVD, we can make it as the source of our healthy files. We have limited access to let him only use files in the DVD or ISO image. After fixing the corruption, you can optionally use start components to clean up any services file, ensuring NSX folder remains healthy and intact. This fails to repair the corruption. Okay, this is not correct because DISM is the more advanced utility. This should be used before and after. This can for and repair system corrupted using system store as a reference. Okay, and if the corruption persists, as I say, we need to repair using in-place upgrade or clean installation. In-place upgrade is a good option before going to clean installation. Okay, let me tell him, give me a real world example to illustrate how this okay, this is not what I need. Okay, I think he's giving us okay, here this is the example. If we go and see what was his example, he's saying, for example, you have noticed the following problems on your Windows PC. Windows update errors. Updates failed repeatedly, like errors like this one, indicating that the update cannot proceed because some components are corrupted or missing. App install issues. You try to install new app from Microsoft Store, but it fails with an error pointing to a problem with the system files. SFC fails to fix corruption. So where is the solution? First, to scan our WinSX folder system files, and then to restore health. What happens? This command repair the corrupted files for in WinSX folder by downloading the clean versions from the Windows updates or using a local repair source if specified. After successfully repairing the component store, clean up outdated or serviced versions using so and so. Okay, this happens. This is used as a WinSX folder. Ensure only the latest versions of the components are retained. Actually, this should be used cautiously because maybe, for example, if you are using, for example, maybe two different versions of the same application and you need both files for or both versions of the same application, so this can be a little bit of a trick. You need to make sure not to use it or to use it wisely to reclaim some space uh, on your C partition. Actually, this is a good thinking. If we have a problem with our C partition and we need to reclaim some space, this can be one of the tools we can use to reclaim some space. Reset. If you are confident the system is stable and no old updates need to be uninstalled, you can use this commandlet. Okay, so what happens? All versions are permanently removed. The baseline of the system is reset to the most recent version of the component. Outcome: Windows Update works. After repairing the component store, updates that were failing with so and so now installed successfully. Microsoft store apps properly. Disk space saved. Takeaways. This is the commandlet, so and so. So anyway, this is a little bit of a good example. If we try to get the same question and ask Claude the same one, if we go and open, can I use it from the same one? Okay, we can use this one. Let him tell him normal and give him this one. So here is his answer. If we go further and try to see, I think he's explaining removing all subsist versions of every component in the component store. So what does this commandlet do? Remove previous versions of updated components, delete unused, use features and packages, compress files. Compress files, so we have, I don't know if this is correct or not. Reset base effect, remove all previous versions of components, keep only the current version of each component, cannot be undone once complete. Important implication, significantly reduces WinSX folder, free some space, improve system performance, reduce system complexity. Disadvantages, cannot uninstall current updates after running, cannot roll back to previous component versions, updates become permanent, future updates can still be uninstalled. When to use it? This is a good thing. Good scenario after major feature updates when disk space is critically low. I think this is a good thing. This is the one that I prefer to use it in this situation. On a stable system with no update issues, in environment where updates rollback isn't needed. Avoid using when system experiencing update problems, testing new updates that might need to roll back, incorporate environments requiring update control. Corporate environments require update control before major system changes. So I think we can use it only in this situation. Best practice. Before running, create a system restore point, backup important data, verify system stability, check available disk space. During execution, do not interrupt the process, keep system powered on, be patient, can take time. After completion, verify system functionality, check Windows Update works, monitor system performance, recovery options. If issues occur after running this commandlet, use the system restore point, perform in-place upgrade, reset Windows if necessary. So a good answer actually, and every AI tool give us a little bit of a tip how we can work with this, work with SFC and DISM. So let me go to the answer again from Claude, and then we can continue with the answer of, I think we have already seen Gemini answer. Let's go and see the answer of ChatGPT. Here we can see this is explain this topic using the PDF. Let's see if he can give us a good answer. Okay, let's go and see.
Hacks how to repair Windows 11 using SFC and DISM. Overview of SFC and DISM. System File Checker, SFC, scans and restores corrupted or missing system files. It ensures system integrity by replacing incorrect files with the correct ones from the Windows Component Store. Deployment Image Servicing and ManSM repairs the Windows System Image and Component Store. DISM is used when SFC fails to resolve file corruption. Steps to use SFC and DISM. Running SFC 1. Open elevated command prompt. Press Win-X. Then select Windows Terminal Admin. Alternatively, type Command in the search bar, right-click, and choose Run as Administrator. 2. Run the command. Type SFC scannow and press enter. Wait for the scan to complete. It may report no integrity violations, corrupt files that were fixed, corrupt files that couldn't be fixed. 3. If SFC fails, run SFC scannow up to 3 times, restarting between each attempt. Disable fast startup and try running the command again. Running DSM. If SFC fails to fix the issue, use DSM to repair the component store. 1. Check system health. Command DSM online cleanup image check health. This checks for corruption but does not fix anything. 2. Scan for corruption. Command DSM online cleanup image /scan health identifies if the image is repairable. 3. Repair the image. Command online cleanup image restore health. This downloads files from Windows Update to replace corrupted components. 4. Offline repair. Use an ISO or bootable media as the source for DISM if your system is offline. DISM online cleanup image restore health source WIM path sources install.wim1 limit access. 5. Rerun SFC. After DISM repairs, run SFC/scannow again to fix remaining issues. Real-world scenario. Imagine a server running a business-critical application starts displaying errors due to system file corruption after a failed Windows update. The administrator, 1. Runs SFC scannow to identify and fix corrupted system files. 2. Finds that SFC couldn't fix all issues. 3. Uses DSM restore health to repair the component store. 4. Reruns SFC to verify the integrity of system files. 5. Successfully restores the server to a functional state without reinstalling the OS. Common pitfalls and best practices. Disk space. Ensure adequate disk space as DISM repairs involve large file downloads. Antivirus interference. Disable antivirus temporarily to avoid conflicts. Source files. Use the correct ISO or bootable media matching your Windows version and architecture for offline repairs. Network issues. DM uses Windows Update by default. Ensure a stable internet connection or provide offline sources. Logs for diagnostics. Check cbs.log, chant logs cbs.log, and dism.dog event.log for detailed error messages. Do not interrupt. Avoid interrupting SFC or DISM processes to prevent incomplete repairs. By understanding and implementing SFC and DISM tools, you can effectively troubleshoot and resolve file corruption issues on Windows 11 systems, minimizing downtime and maintaining system reliability.
So the answer is a little bit not better than Gemini, but it also contains some points. But one of the things here I need to mention that using SFC, and here this section when he's asking to run SFC 3 times, restarting after each attempt, this if you are using SFC offline, okay, and disable fast startup. This is when are you scanning or using SFC in offline mode, okay? He didn't mention that, so we need to focus on it. This is not online repair, this is offline repair. So anyway, it's a good answer, but I think still missing some points. If we go to Claude and see the answer of Claude, if we go and open the answer of Claude, here you go, this is also the answer of Claude. Let's see the answer. Here is saying Windows 11 has two main tools for repairing system files. We have System File Checker, checks and repair Windows system files. Deployment, image servicing and management, DISM, repairs the Windows component store and system image. You need to clarify these 2 points. Common scenarios when to use these tools. Windows is showing errors or behaving strangely. Applications are crashing unexpectedly. Windows features or update fail to install. System performance degraded. After malware removal to verify system integrity. Repair process flow. Always follow this order. Run SFC first. If SFC fails, run DISM. After DISM completes, run SFC again. So this is a good point. Was not said by Gemini or ChatGPT, which is very true. You need to do this in this order. So the first thing is to run SFC scan now. This is the online repair method. Takes about 15 to 30 minutes to complete. must be run as administrator. Do not interrupt the scan. Possible outcomes. So Windows Resource Protection did not find any integrity violations, no issues found. Windows Resource Protection found corrupted files and successfully repaired them. Issues fixed. Windows Resource Protection found corrupted files but was unable to fix some of them. Proceed to DISM. Okay, I like the layout of the answer. Okay, so running DISM, now we can check for health. If we found issues, scan for health. This is a basic check. This is a through or a deep scan or a deep health check. Then we can repair it using the last one. So final step, after DISM completes, run SFC one more time. So this is a good thing. Common pitfalls to avoid. Running order mistakes. Do not run DISM first. Do not skip running SFC after DISM. Do not interrupt the scans. Okay, environmental issues. Do running order mistakes. Environmental issues. Do not run in normal command prompt. It must be admin. Do not run with antivirus active. Temporarily disable. Do not run with low disk space. Need at least 10 GB free. Recovery issues. Do not attempt repairs without a backup. Do not restart during repairs. Do not force shutdown if process seems stuck. Okay, best practice. Before starting, create a restore point. A good thing. Backup important data. Ensure stable power supply. Have at least 10 GB free space. Disable antivirus. Close all applications. During process, be patient. Repairs take up to 30 minutes. Monitor the process or the progress. Keep computer plugged in. Do not run other programs. After completion, check for logs for details. Test system functionality. Re-enable antivirus. Create new restore point if successful. Troubleshooting. If repair fails, we need to see the logs. Okay, this is for SFC. And I think DISM. We need the SFC and the DISM.log. Try running in safe mode. I don't know if this is a good thing to do. Use Windows installation media for offline repairs. Okay, consider in-place upgrade. When to escalate. Consider escalating to senior IT or Microsoft support if both DISM and SFC and DISM failed. Log shows unusual errors. System wouldn't boot normally. Data loss occurs during repair. Recovery options. If repair fails completely. So this is one good thing actually. System restore. If it fails. In-place upgrade. Keep files and apps. Reset Windows. Keep files but not the apps. Clean station. This is a good order. I think the best answer from my point of view is this for Claude. He is giving us a very, very practical list we can use as a reference for dealing with the situations like Windows working in a strange way or something like that. But anyway, each one of these give us a tip to complete the answer. Okay, so we can see here that Gemini give us an answer, ChatGPT give us an answer, and Claude. So let's continue with the Gemini, or return back to Gemini. Here I'm asking him to design a set of hands-on exercise on how to repair Windows using SFC and DISM based on the notes or the PDF. So let's see the answer. Here is some exercises that will help us to learn more about these two tools. If we go there and ask him to explain it, let's see what will be the answer. Okay, here we go. We have like this one, and let's read it.
Okay, here are 6 hands-on exercises designed to teach junior IT administrators how to repair Windows 11 using SFC and DISM, based on the provided PDF and targeting those with a beginner understanding of Active Directory. These exercises will be practical, include verification steps, and touch on best practices. Required environment and tools. Virtual lab. Each user should have access to a virtual lab environment. Each should have at least 2 virtual machines. DC01. A Windows Server VM acting as a domain controller for basic AD interaction. Win11 test. A Windows 11 VM joined to the domain, used for testing and repairs. Software. Windows 11 installation ISO for DSM source files. Access to an elevated command prompt and PowerShell on the Windows 11 VM. Internet access. The Win 11 test VM should ideally have internet access for Windows Update. If not, you will have to use install.vim. Permissions. User should have local administrator rights on the Win 11 test VM. Exercises. Exercise 1. Basic system file check with SFC. Objective. Learn how to use SFC to scan for and repair corrupted system files. Scenario. Several users report that some built-in Windows 11 apps, like Calculator and Photos, are crashing randomly. Step-by-step instructions. Log into the Win 11 test VM as a local administrator. Open an elevated command prompt. Right-click Run as administrator. Type the following command and press Enter. SFC/scan now. Observe the scan progress. Expected outcome. SFC will scan all protected system files and attempt to repair any corrupted files it finds. Verification steps. Check the SFC output. Look for messages indicating whether integrity violations were found and whether they were successfully repaired. Test the previously crashing apps, Calculator, Photos, to see if they now function correctly. View the cbs.log file by opening Windows Terminal Win+X with Command Prompt or PowerShell and type one of the following commands. For the command prompt profile, Finster/C, SR, %Window%backslash logs backslash cbs/cbs.log, %user profile %desktop/sfc.txt. For PowerShell, select string sr$nv, winder/logs /cbs/cbs.logs, line $nv, user profile /desktop/sfc.txt. Troubleshooting. This command will create a sfc.txt file on your desktop. Open it with Notepad and see its contents. It will help you to find what files are broken and where /weren't fixed. Exercise 2. DISM. Check component store health. Objective. Learn how to use DISM to assess the health of the Windows component store. Scenario. SFC reported that it found corrupt files but was unable to fix some of them. You need to check if the component store is healthy. Step-by-step instructions. On the Win 11 test VM, open an elevated PowerShell window. Type the following command and press Enter. DISM/online/cleanupimage/check health. Expected outcome. DISM will check the component store for corruption and report its status. Verification steps. Examine the DISM output. Look for the following possible results. No component store corruption detected. The component store is healthy. The component store is reparable. Corruption exists, but DISM can likely fix it. The component store is not reparable. You'll likely need a more advanced repair method like an in-place upgrade or a Windows reset. Exercise 3. DISM. Repair component store with Windows Update. Objective. Understand how to use DISM to repair a corrupted component store using Windows Update as the source. Scenario. The component store is corrupted and you need to repair it using Windows Update. Step-by-step instructions. Ensure the Win 11 test VM has internet access. Open an elevated command prompt. Type the following command and press Enter. DISM/online/cleanupimage/restore health. Expected outcome. DISM will download the necessary files from Windows Update to repair the component store. Verification steps. After DISM completes, check the output for a success message. Rerun DISM/online/cleanupimage/check health to verify that the component store is now healthy. Run SFC/scan now to make sure any corrupt files found previously have been repaired. Exercise 4. DISM. Repair component store with a local source. Objective. Learn how to use DISM to repair the component store using a local Windows 11 ISO as the source. This is useful when the computer doesn't have internet access or if you want to control the source files. Scenario. The component store is corrupted. The Win 11 test VM doesn't have internet access or is pointing to an internal WSUS that is down. so you need to use a local ISO as the repair source. Step-by-step instructions. Mount the Windows 11 ISO on the Win11 test VM. Double-click the ISO file. Note the drive letter, e.g. Open an elevated command prompt. Determine the index number for the installed Windows 11 edition by using the following command. DISM/getWinInfo/vim file. /sources/install.vim. Replace E with the correct drive letter if necessary. Type the following command and press enter, replacing E /sources/install.vim. 6 with your installation media drive and index number. This is an example. DISM/online/cleanupimage/restorehealth/source vim E /sources/install.vim 6/limit access. Expected outcome. DISM will use the files from the mounted ISO to repair the component store. Verification steps. Check the DISM output for a success message. Rerun DISM/online/cleanupimage/check health to verify that the component store is now healthy. Exercise 5. Offline repair with SFC. Objective. Understand how to use SFC to repair a Windows installation that won't boot. Scenario. The Win11 test VM fails to boot after a driver installation, and you suspect system file corruption. Step-by-step instructions. Boot the Win11 test VM from the Windows 11 installation ISO. On the Install Now screen, select Repair Your Computer. Navigate to Troubleshoot Advanced Options command prompt. Use diskpart and then list volume to identify the drive letters for the recovery partition and the Windows partition. Type the following command and press enter, replacing the drive letters with those from your system. SFC/scannow/offwinder equals F //offwinder laughing face :\Windows. Replace F with the recovery partition drive letter and D with the Windows partition drive letter. Expected outcome. SFC will scan the offline Windows installation and attempt to repair any corrupted system files. Verification steps. Check the SFC output for any reported errors or successful repairs. Reboot the VM normally and see if it boots successfully. Exercise 6. Analyze and clean up the WinSXS folder. Objective. Learn how to analyze the WinSXS folder size and perform a cleanup to reduce its size. Scenario. Disk space on the Win11 test VM is running low, and you want to see if cleaning up the WinSXS folder can help. Step-by-step instructions. Log into the Win11 test VM as a local administrator. Open an elevated PowerShell. Run the following command to analyze the WinSXS folder. DISM/online/cleanupimage/analyze component store. Review the output to see the actual size of the WinSXS folder and whether cleanup is recommended. If cleanup is recommended, run the following command. DISM/online/cleanupimage/start component cleanup. Expected outcome. The /analyze component store command will provide a breakdown of the WinSXS folder size. The /start component cleanup command will remove outdated and superseded files, reducing the folder size. Verification steps. Rerun the /analyze component store command and compare the output to the initial analysis. You should see a reduction in the actual size of component store. Bonus challenge. Scripting a monthly maintenance task. Objective. Create a PowerShell script to automate monthly system maintenance, including SFC and DISM checks, and schedule it using Task Scheduler. Challenge instructions. Write a PowerShell script that does the following. Checks the component store's health using DISM. If the component store is reparable, repairs it using Windows Update. Runs SFC to scan for and repair system files. Logs the results of each operation to a text file. Use Task Scheduler to schedule the script to run monthly. Expected outcome. The script will automatically perform the maintenance tasks and log the results. Verification steps. Manually run the script and verify that it works correctly. Check the scheduled task in Task Scheduler to ensure it's configured properly. After a month, check the log file to see the results of the automated maintenance. Best practices and security considerations. Always test in a lab environment before applying repairs to production systems. Document all steps and results. Be cautious when using the /reset-based parameter with DSM as it prevents the uninstallation of previous updates. Regularly monitor system health and logs. Stay updated on the latest Windows 11 repair techniques and best practices. These exercises provide a solid foundation for junior IT administrators to understand and use SFC and DSM effectively. Remember that these are just starting points, and there's always more to learn about these powerful tools. By practicing and exploring further, they'll become proficient in maintaining the health and stability of Windows 11 systems.
So a perfect answer from my point of view. Very, very good answer. We can see how he is giving us different scenarios and exercises how to use uh, those utilities, and it is in a step by step and very simple to follow. Okay, if we go now and let's see ChatGPT, if I give him the same prompt to generate some exercises to work with or to make us learn how to uh, use SFC and DISM. Now we can do like that.
Here is a structured set of 6 hands-on exercises designed for junior IT administrators to learn how to repair Windows 11 using SFC and DISM. Based on the provided notes, these exercises include objectives, realistic scenarios, detailed steps, and verification tasks. A bonus challenge is also included for advanced learners. Exercise 1, running SFC to repair system files. Objective, learn how to use the SFC/scanout command to detect and repair corrupted system files. Scenario, a user reports slow performance and occasional crashes on their Windows 11 machine. You suspect system file corruption. Instructions. 1. Open command prompt as an administrator. Press Win-X and select Windows Terminal Admin. 2. Run the following command, SFC/scanout. 3. Wait for the scan to complete. 4. Note the result. No integrity violations found. System files are intact. Corrupted files repaired. Issue resolved. Corrupted files cannot be repaired. Proceed to exercise 2. Expected outcome. A summary of the scan status. Verification steps. 1. If corruption was repaired, confirm system performance is improved. 2. Check the cbs.log for detailed results. Find //sent windart-log cbs.log. Sent user profile sent desktop sfc results.txt. 3. Open the sfc results.txt file on the desktop and review entries. Exercise 2. Using DSM to repair component store. Objective. Understand how to repair the Windows component store with DSM. Scenario. SFC scanout indicates some system files couldn't be repaired. The component store may be corrupt. Instructions. 1. Open command prompt as an administrator. 2. Run the following commands sequentially. Check health. DSM online cleanup image check health. Scan for issues. DSM online cleanup image scan health. Repair component store. DSM online cleanup image restore health. 3. Monitor the output for errors. Expected outcome. DSM reports that the health of the image is restored. Verification steps. 1. Run SFC scanout again to ensure system files are repaired. 2. Verify logs. Check dsm.log at sent windart-log dism.log. Exercise 3. Performing an offline SFC scan. Objective. Repair system files on a machine that cannot boot into Windows. Scenario. A machine fails to boot due to suspected file corruption. You need to repair it using offline tools. Instructions. 1. Boot the system into Windows Recovery Environment, WinRe. Use a bootable USB or press Shift F8 during startup. Select Command Prompt from Advanced Options. 2. Identify system and boot partitions. Disk part list volume exit 3. Run the offline SFC scan. SFC/scanout/offboot dir boot partition /off window equals system partition, Windows. Replace boot partition and system partition with the identified drive letters. Expected outcome. The offline scan reports that corrupted files are repaired. Verification steps. 1. Reboot the system and verify it starts normally. 2. Check cbs.log in the offline Windows directory for details. Exercise 4. Analyzing and cleaning the component store. Objective. Learn to analyze and clean up the WinSXXS folder to optimize storage and system health. Scenario. A Windows 11 machine is running low on disk space. You need to clean up the component store. Instructions. 1. Open command prompt as an administrator. 2. Analyze the component store. DSM online cleanup image analyze component store. 3. If cleanup is recommended, execute DSM online cleanup image start component cleanup. Expected outcome, the component store size is reduced. Verification steps. 1. Rerun the analysis command to confirm reduced size. 2. Check free space on the system drive. Exercise 5. Using DSM with a local source. Objective. Use an offline source for DSM repairs when the system lacks internet access. Scenario. A server in an isolated network requires component store repair, but it cannot access Windows Update. Instructions. 1. Mount a Windows 11 ISO. Note the drive letter, e.g. G. 2. Run the DSM repair command with the local source. DSM online, cleanup image, restore health source, WimG sources install.1 limit access. 3. Replace G with the mounted ISO's drive letter. Expected outcome. DISM reports successful restoration of the component store. Verification steps. 1. Check DISM.log for successful completion. 2. Run SFC Scano to confirm system file integrity. Exercise 6. Troubleshooting a DISM failure. Objective. Diagnose and resolve common issues with DISM. Scenario. A DSM operation fails with the error, the source files could not be found. Instructions. 1. Review the DSM.log for specific errors. Notepad sent windarprint logs DSM.log. 2. Verify the ISO source path is correct. 3. Use the /scratchdir option if disk space is low. DISM online cleanup image restore health /scratchdir/temp. 4. Rerun the repair command. Expected outcome. DSM completes successfully after troubleshooting. Verification steps. 1. Validate with DISM check health. 2. Confirm system stability. Bonus challenge, automating repairs with PowerShell. Objective, automate SFC and DISM operations using PowerShell scripts. Scenario, as an IT administrator, you want to automate repair tasks across multiple machines. Instructions. 1. Create a PowerShell script to run SFC Scano. Run DISM commands based on SFC results. Log outputs to a file. 2. Example script snippet. PowerShell.log file equals C repairlog.txt. SFC Scano out file log file. DSM online cleanup image restore health out file -append log file. 3. Execute the script and monitor logs. Expected outcome. The script automates the process and logs results for later review. Verification steps. 1. Check the log file for successful operations. 2. Review system health and performance. This set of exercises provides a comprehensive learning path for junior IT administrators, combining real-world scenarios, step-by-step instructions, and troubleshooting techniques.
So as we can see, the answer is a little bit not better than Gemini. I think Gemini is better, but it's giving us some other maybe exercises. There is similarity between the exercises provided by Gemini and by ChatGPT, but there is one or two differences, or one or two exercises that was introduced by ChatGPT, which is good also, and give us more let us know different situations how we can handle corrupted file systems. Okay, so if you go to Claude and ask it the same question, if you go further and ask him to design hands-on exercise, let me see here or read the answer for you. Windows 11 repair hands-on exercise, required environment, Windows 11 Pro Enterprise Virtual Machine for practice, administrative access to the VM, at least 20 GB free space, Windows 11 installation media, ISO image, basic understanding of PowerShell and command prompt, virtual machine snapshot capability. Basic system file check integrity, a difficulty beginner, learn to perform basic system file integrity verification using SFC. Okay, here is the first scenario. A user reports that their Windows 11 laptop experiencing occasional application crash. As the first troubleshoot step, you need to verify system file integrity, prerequisites Windows 11 VM, administrative access. Now we need to create a system restore point, which is a good one, by the way. Checkpoint. So this is, I think, if this VM is a Hyper-V VM. He is taking a snapshot from the VM before running SFC. But let me check if this commandlet is correct. I think it's correct. If we go there and get this one, let's see what this commandlet will do. So here we go, checkpoint computer. So the description of it creates a system restore point on a local computer. System restore points and checkpoint commandlets are supported only on clients systems such as Windows 10, so cannot create more than one check. So I think this is not a snapshot for the VM. This is a restore point. Okay, so there is a difference between a snapshot for a VM and a restore point for a machine. Remember, I think he's talking about this. Let me show you what he's talking about. If you go like that and tell him properties, and then system protection, and then here we tell him to create a restore point. But how we can create a restore point, or what? We will create a restore point on the partition that the system restore is activated on. Okay, so here he's talking about this. Okay, if we go there, actually a good step to take. Okay, checkpoint so and so before SFC scan, and then we can open Windows Terminal and run SFC scan, and then we can see the results or filter the results using this commandlet. Expected outcome SFC completes is one of the messages. Windows Restore or Windows Resource Protection did not find any integrity violations. Windows Restore Protection found corrupted files and successfully repaired them. There is another one. He didn't able to fix it, so this is a missing one. Okay, verification. Check the SFC text on the desktop, the filtration. Verify no error messages in the event viewer. So this is one thing we need to focus, where we can find this in the event viewer. So let me stop there for a moment. So let's continue, guys. I think here we need to know where we can get from the event viewer the errors concerning the SFC, or not the errors, the successful or errors concerning SFC. Let's try to ask Perplexity, because I think this is the most accurate one. If you go there and ask Perplexity, XDI, what are the events ID related to SFC and DISM in Windows Event Viewer? Let's see if we can get an answer. Okay, he's saying that specific events ID are associated with the operation of system file checker and deployment. These tools are crucial for so and so. So event ID related to SFC, event 1001. This ID often logged when SFC detects issue during its operation, indicate the system has encountered an error, often leading to a crash or a performance issue. The log may not provide detailed information about the cause, making troubleshooting challenging. Okay, event 100. This can appear in relation to SFC operation, particularly when it logs the result of a scan or a repair process. It may indicate that SFC has completed its verification and repairs successfully. Event 4101. This ID can indicate SFC has found and repaired corrupted files during its operation. It's logged in the cbs.log file, which contains detailed results of the SFC scan. So, okay. Related to DISM, again, similar, we have event 100. Okay, may event when performs operation related to system image servicing is significant signifies that a cleanup or restoration process was initiated. Event 14098, this indicated that DISM had encountered an issue when they're trying to repair the Windows image. It can signal the component store is corrupted and further action required. Okay. Event 20001, this event may be logged with DISM successfully completes a restoration operation on the Windows image, indicating that the system is now in a healthy state. General notes on using SFC and DISM. Both tools can run from an elevated so and so. The logs are so and so. Okay, let me try to ask ChatGPT its online feature, or we can ask again Copilot as something here. We can ask Copilot and then we can ask again ChatGPT. So we have 101 or 1001, 1002, 1003, 1004, and we have 10,010, 10,020, 10,021, 10,022. So there is some similarities, but not all of these was listed here. For example, we can see that some of them are 1001. Okay, we have 100, which is not listed here. 4001. Okay, a follow up here is the analyze the log entries. So this is one good thing. I think analyze log entries that SFC generates. I think this is one good thing we need to put or to check. Okay, so we have a lot of things. We have a couple of events, and as for DISM, I think you got one of them is 2001. We have seen here. Let me go further. We have no. Okay, he didn't give us this one. So there is a couple of events. Let's see. ChatGPT can give us a different answer. So we can just click like that, and then we have. Let's have a new chat. So here you go. We can tell him search like this and put this one. So he only got us the logs concerning the DISM and SFC, not through the event viewer. So he didn't get the correct answer that I need, but anyway, we can see here that there is a couple of events we can check and see if it is related to the SFC and DISM, and we can check the DISM.log and the CVS.log, so we can check both. So let me see this one. This is how to analyze the SFC. View the log, and here we go. This was set by Mr. Lo van der Poel. Interpret the log file entries. So we can see here in groups of 100 the following CBC note file details, cannot repair file details, repairing corrupted files, data collection. So anyway, I could not see. It is a file, okay, not that good anyway. So now we have seen a lot of errors we can check in the event viewer, I think from the system. Let's go to exercise 2. DISM health check and repair. Learn to assess and repair Windows image health using DISM. After an XFC you found corrupted files that cannot be repaired, you need to use DISM to repair. Take VM snapshot. So now he is taking, before in the first or the previous exercise, he's taking a checkpoint or system restore point, and now he's taking a snapshot. Okay, so I think we can take both snapshot and the checkpoint. Take VM snapshot, then we check for the health, and then we scan again. If issue was found, scan health, then restore health. All of this will be done online. Run SFC again. The outcome, DISM report successful completion. Follow up SFC scan shows no integrity violation. Verification check DISM logs. Verify system stability. Exercise 3, offline system repair. So all of these are online. Now we go to the offline. Difficulty intermediate. I think this is a good classification because the previous one was very simple. This needs some knowledge. The offline system repair. Learn to repair Windows when it's not boot normally. System wouldn't boot into Windows. You need to perform offline system repair using Windows installation media. So step boot VM from Windows 11 installation media. Select repair your computer on command prompt from advanced options. Identify Windows drive letter, the system drive letter, disk part list volume, and then run SFC to identify the system and the boot partition, which regularly or most often they are the same partition. Okay, run offline on servers. By the way, you will see that the boot directory is not the C. Sometimes it is the system partition. There's something called system partition, and it's hidden, and you don't have a drive letter for it. So again, this is the C partition, and then we will run the DISM. But here is something. Offline, you need to run offline DISM. You need to have internet access. Okay, this is not correct. We need to add limit access at the end and identify a source or the local source of files. This is not correct. It needs to be changed. Expected outcome: successful completion of offline repairs. System boots normally. System boots successfully. Check system and application event logs. Component store, analyze and clean up. This is the same as ChatGPT and Gemini. A system running on low on disk space. Investigate shows the WinSSX folder is very large. Here is the command lib to analyze the folder. Record the size. Cleanup. For aggressive cleanup, you tell him reset base. Reanalyze component store. Reduced WinSX folder. Expected outcome. No system functionality loss. Verification. Compare before and after size. Test Windows update functionality. Verify system features still work. Advanced troubleshooting scenario. This is more advanced exercise. Learn to diagnose and repair complex system issues. Scenario. A system exhibits multiple issues. Windows update failures, feature installation errors, slow performance, application crash. Steps. First of all, create diagnostic reports. This we are checking there is some issues concerning the Windows update failures. We get or we can read the errors from the Windows update log. Let me see if this commandlet work. This will work from PowerShell. Let me see if this commandlet is really working. Yes, and let's see. We have a stable version. If we try like this one. So here is the Windows. Okay, so he's getting all of the logs. So there is something else. Okay, so here are the logs of the Windows. We can see here these are the location of the logs. Okay, so these are Windows update logs. Okay, and the output, the command completed successfully. Okay, so these are logs, but you cannot read it from here, but you can go to the folder and check the logs. Okay, we can see it from here, or you can get it through the event viewer. So again, a good thing or a good exercise, we can just leave it like that and continue with the assumption. Check CBS logs for what? Check first update failures. Okay, this will be explored by seeing the Windows update log. As for feature installation errors, you need to check the CBS log. It will contain errors concerning the features, and later the SFC results will be included in it. So this is a good thing, a very, very good example to see the errors. We have seen this in a couple of videos before, how we can check the CBS or analyze the CBS for errors. Okay, then so he is checking the logs too. So the first one is to check the Windows update log. The other three, we can check them from the CBS log. Okay, then we will uh, run health check. I think this the order is not correct. We need to run SFC, then we can run DISM. Okay, first one, then second one, and clean up. Here he is suspecting that the problem is with some Windows updates, so he's cleaning old Windows updates. Okay, so he's cleaning them to clear any cached Windows updates or any corrupted Windows updates that are cached. Okay, and then this is a good thing. Okay, all of these are services related to the Windows update components. He is just stopping all of them and then restart them again. So this is basically like cleaning up corrupted Windows updates to solve the issue concerning update failures. Okay, checking the log and then making some SFC scans, uh, clearing all Windows updates, and then restarting the Windows update services to check or to get the update again. Okay, if this is a corrupted one, you will just clear the old update and re-download it again. Okay, expected outcome, he needs first to give us, okay, net stop and then restart. So we need to start all of these services. For example, this is Windows Update service, cryptic service, bits. All of these I think are related to Windows Update maybe. I think cryptic service, this is bits. I know this is bits for the Windows or for transferring Windows updates or for downloading Windows updates. All of these are WA user V. I know this is for the WSOS service maybe, or the Windows Update service, cryptic service. I didn't know this service. Anyway, expected outcome, all service running properly, Windows Update working correctly, system stability restored. So he is solving two issues in one thing. First, he will here he will scan for the corrupted file systems. But again, if the SFC didn't work, you need to make a restore health, and you need to clear the Windows updates. Okay, so I think this is a good example. But I think he's focusing on Windows updates. But also, I think the health restore will, or the SFC will clear also any crashing things concerning feature installation errors and slow performance and system crash. Okay, anyway, so I think all of these steps can solve the issue, but you need to give us the restart commandlets for these. Let me see something here. Let's copy that and ask another question. Are all of these services related to Windows update? Just to make sure that all of these services are actually related to it. So yes, these services you mentioned, Windows Update, okay, cryptographic service, provide three management services, catalog database service, which confirms the signature of Windows files and allows new programs to be installed, protected root service, which adds and removes certificates from trusted root certificate authority store for the computer, and key service, which helps enroll the computer. So one of these is catalog database service, which confirms the signature of Windows files and allow new programs to be installed. I think this is related to the Windows Update. Background intelligence service, transfer files in the background using idle network bandwidth, is used by Windows Update to download updates to the system. Windows installer modifies and removes application provided as a Windows installer package. So I think these are all maybe Windows Update are not MSI packages. installation of new programs. So I think all of them are related to each other. Yes, these services you mentioned are integral to the Windows update process. So stopping these services is a common troubleshooting step when addressing Windows update issues. So this is a common standard for troubleshooting Windows update issues. For instance, stopping these services allow for the renaming or deletion of the software distribution and caret2 folders. So yes, I think I have seen this procedure before. You can go to these two folders that are related to Windows updates. You delete the content in it or rename it, okay? And by restarting these services, I think they will be recreated, okay? Which can become corrupted and cause update problems. After performing such maintenance, restarting these services ensure that Windows update can function correctly. So I think this is correct, okay? So he didn't also mention that in the answer provided by Claude, but I think that deleting the old updates, I think this will be done using start component cleanup. So I think this will be done using this commandlet. Anyway, so this is a good exercise and a different one. Emergency recovery scenario. Learn to recover severely damaged Windows installation. Scenario: Windows fails to boot even in safe mode. Multiple files are corrupted. So boot from the installation media, access command prompt, mount and check system drive. So here is a good thing. Sometimes the C partition, okay, or the partition that contains the operating system will lose, or you cannot, it is not assigned a drive letter. Sometimes you can go through the command prompt using or through a bootable flash drive of the operating system, and when you check the partitions, you will see your system partition doesn't have a drive letter. So sometimes you need to give it a letter so you can scan it. Okay, so this is how we can do that. This part list, select volume, but here not volume. Here is select volume 1 or something, not volume C. Here we have a number for the volume 1, and then assign letter equal C and then exit. So here is a problem with some of the commandlets here. Then run comprehensive repairs. Here you run DISM and it will run through the source files on your bootable flash drive, and here is one for the index. He didn't give us an explanation for one, but I know this is for the index of the Windows operating system. If you have a multi ISO image, multi-image that contains, or an ISO that contains multi-images for Windows 11, okay? So limit access, you don't have access to the internet. Check file system. This is not check the file system, this is a check disk errors, okay? So this check disk errors, okay? So this is also good. Maybe your system is corrupted because the files or you have corrupted file systems because during to a hardware or a bad sector in the hard disk. So this can repair this one. So I think a good exercise, by the way, but he didn't give us the SFC commandlet, he didn't use it, but actually a good exercise also, and some of them I have already used in similar situations, okay? Using check disk, I have already done this before. As for assigning drive letter, this was done also in one of my videos. So we have expected outcome, system boot successfully, no corrupted file reported, stable operation, verification, successful boot, clean system logs, all features functional. Bonus challenge, automated health check script. Create a PowerShell script that check system health, report issues found, attempts automatic repairs, logs all actions, email results to the administrator. He's leaving this to us as an exercise. Safety notes, always create system restore points. This is a good one. Backup important data, document all changes, have a recovery plan, test in a VM first. So I think this is a good exercise, or some good exercises. Common pitfalls: running repairs without admin rights, interrupting repair operation, insufficient disk space, skipping verification steps, not checking logs. So I think this is all are good exercises. So In the upcoming video, with God will, we will try to discuss the same topic, but through a conversation between the senior IT and our junior IT. Another way to explain SFC and DISM, not through steps or exercises, but through a dialogue between two ITs, a junior IT that have limited knowledge and a senior IT that is giving him more detailed explanations. So we will see how this will lead to revealing a lot of information also that can be added to our knowledge after seeing the exercises and the explanation of the different AI tools. So in the upcoming videos, God will, we will talk about the same topic through a dialogue, and this will be done using Claude 3.5 Sonnet and using ChatGPT and using Gemini. So hope this video informative for you all, and thank you all for viewing. Thank you so much.